Hello there. We start off with the chapter three-dimensional geometry. Now, this is the first class of the chapter. We have divided the chapter into two classes. In the first one, we are discussing lines in space, and in the second one, we are going to talk about planes. So, in today's class, we are going to deal with first the direction ratio and direction cosine of a line. Then we are going to talk about equation of a line, then angle between two lines, and finally skew lines and the shortest distance between them. To begin with, direction ratio and direction cosine of a line. Now, from the previous chapter, we already have the idea that what we mean by direction ratios and what we mean by direction cosine. Now, the idea of direction ratio and direction cosine for a line remains all the same, because whenever we are trying to talk about direction ratio and direction cosine, we generally talk about a line actually. So let us consider, if I have a vector r. Now there is a small printing mistake. If we consider the vector r with the components ai plus bj and ck, then obviously a, b, c, these are called the scalar component or the direction ratios of the vector r. Fine. Now, if I consider the unit vector, now unit vector is always represented by a cap. So if r vector with an r and on the top there is an arrow, then the unit vector is written by the same r with a cap on the top, right? So that means it is the vector in the same direction of the vector r, but with the magnitude 1. And how do we get it? We divide the vector by its modulus, and whatever we get, that is called the unit vector. Now, the components of the unit vector, if you see, that is a by root over of a square plus b square plus c square, b by root over of b square a square plus b square plus c square, and c by root over of a square plus b square plus c square. Now, these components of the unit vector, they are the direction ratios of the unit vector for sure, but as it is the direction ratio of a unit vector, they are given a special name, and they are called direction cosines. Now, why? We definitely explained that in our previous class. So please go and check into the previous class, that is the chapter vector. There you will find the details given. So you can just go there and check it if you want to. Now, the good thing about the direction cosines, that if you square and add them, then that gives you 1, which is pretty easy to see. Now, if I'm talking about a vector, now vector is basically, it is a directed line segment. So therefore, whatever we talk about vector is applicable for lines as well. So whenever we are talking about direction cosine or direction ratio of a vector, so basically we are actually talking about direction cosine and direction ratio of a line. So therefore, the same way, if I have a straight line passing through the point x1, y1, z1 and x2, y2, z2, then the direction ratio of that line is given by x2 minus x1, y2 minus y1 and z2 minus z1. So this can be related to the direction ratio of a vector which has got an initial point at x1, y1, z1 and the terminal point at x2, y2, z2. So basically, any straight line can be considered in the form of a vector. Now let us take few problem and understand. So it is given, if a line makes angle 90 degree, 60 degree and 30 degree with the positive direction of x, y and z axis respectively, find its direction cosines. Now, as we have done in our previous chapter, that is the chapter of vectors, that If any line makes the angle alpha, beta and gamma with the positive direction of the axis, then cos alpha, cos beta and cos gamma gives the direction cosines. So all we need to do is just find the cosines of these angles, and whatever we get, that is our direction cosines. So let me just take you back to the previous slide. Yep. So the direction cosines are cos 90, that is 0, cos 60, that is half, and cos 30, that is root 3 by 2. So these are the direction cosines. Number 2, if a line has direction ratios 2, -1 and -2, determine its direction cosines. Now remember, to find the direction cosines from the direction ratios, all we need to do is divide by the square root of the sum of the squares of the direction ratios. So therefore, if these are the direction ratios given, again there should be a -2, which I missed. So it is 2 by under root 2 square plus -1 whole square plus -2 whole square. So that minus is not printed. But it really doesn't make much difference, because as we are squaring it, it is going to give me the same number. So just here there will be a minus sign. There should be a minus sign, so just see to it here as well. Fine. So therefore it is 2 by 3 minus 1 by 3 and also minus 2 by 3. So you can make the change in either of the case if you are considering the question as 2 minus 1 and 2. So this is our direction ratios. So here also there will be a negative sign. Fine. Okay. Next, find the direction cosines of the line passing through the point P 2, 3, 5 and Q -1, 2, 4. So this is basically the same as finding the vector passing through the point P and Q. So therefore the direction ratios will be 2 minus of -1, 3 minus of 2 and 5 minus of 4. So that gives you 3, 1, 1. So therefore the direction ratios are 3, 1 and 1. Now let us move to the next concept, that is the equation of lines. Now in this question they ask you to find direction cosines, so you just divide it by the modulus and you get your answer. Now equation of line. For equation of line we require two things, that is we need to know a point on the line, and along with that we require the direction of the line. Now if we know these two things, we can write the equation of a straight line in three-dimensional space. Now let a vector, that is the position vector of the point which is on the line, now it can be any point, and the direction is given by the b vector. Now you can see there are repeated use of letters, but let us not confuse that this is a vector, this is also a vector, and these are scalar components. So I think that part is clear to all of us. So therefore r vector is equals to a vector plus t vector, that is the equation of the line in vector form, and where r vector is the current coordinate, that is x, y and z. Now if we write the same thing in Cartesian form, that is the scalar form, so if I consider x1, y1, z1 to be the point on the line, and ABC is the direction ratio of the line. Now obviously remember that direction ratios basically work like the slope in two dimension. So whatever we call as the slope in two dimension is basically the same thing which is direction ratio in three dimension. So therefore the equation of the line is going to become x minus x1 by a equals to y minus y1 by b is equals to z minus z1 by c, that is equals to t. T is the same parameter. Now what does t do? T is like the factor which tells us what is the ratio between x minus x1 by a, y minus y1 by b, and z minus z1 by c. This is called the symmetric form of the straight line. Now obviously we have symmetric form of straight line in 2 dimension as well, but which we don't make use of much. If you remember that there is something called x minus x1 by cos theta, that is equals to y minus y1 by sine theta. So if you remember this form, this is called the symmetric form of straight line in 2 dimension. Sorry. Now, as we can write the equation of a straight line in 2 dimension in many better forms like the slope intercept form or the intercept form or the general form, so therefore we don't make use of this symmetric form in case of 2 dimension, but in case of 3 dimension this is the only form available to write the equation of straight line. Now if instead of the direction of a straight line, if I am given 2 points on the line, so previously I was given a point and then I was given the direction, but in the second case if I am given 2 points on the straight line, so let us just tally this with our let us just tally this with our 2 dimension. That is, the first one is basically what we have in 2 dimension as the point slope form. So we are given the point and we are given the slope of the straight line, and so we can find the equation of the straight line. Similarly, in the second case, if we are given 2 points, that is the point form or 2-point form of a straight line in 2 dimension. So similarly, drawing an analogy to 3 dimension, if I am given position vectors of 2 points on the straight line, then the equation of the straight line can be written as r vector equals to a1 vector plus t into a2 minus a1 vector, right? So a2 minus a1, so this is going to give us the direction of the straight line. And writing this in the scalar form, we have this, which is pretty easy to see why. Now let us move to the next idea. Now I'm going to just give you the both vector as well as the Cartesian side by side so that you can parallelly understand what is going on. So if I'm taking 2 equation of straight lines, then how to understand if they are parallel or intersecting, and in case of lines in space there is a third kind of lines which are called skew lines. So let us see how to understand that. Now how to understand they are parallel? If the 2 equations given, if either in vector form or in the Cartesian form, so let us first discuss the vector form. 2 equation of lines given, and to understand if they are parallel, then their direction must be same. So therefore the direction of the first line must be a scalar multiple of the direction of the second line, or in the Cartesian form the ratio of the direction of both the lines must be equal. Then next one, perpendicular. Now perpendicular, obviously we remember that dot product must be 0. So therefore for both the lines, if the dot product of the direction of both the lines is 0, that means the lines are perpendicular. And intersecting, if a2 minus a1 dot b1 cross b2, that is 0, or which translates in the Cartesian form as if this particular determinant is 0. Now let us take few examples. Find the vector equation of the line passing through the point 1, 2, 3 and parallel to the vector 3i plus 2j plus minus 2k. Now, obviously, parallel to the vector means that this is the direction, because parallel lines have same direction. So, if it is given that it is parallel to a particular vector, that means the line is also having the same direction. So, therefore, the equation of the line is given by, now obviously the point is given in Cartesian coordinates. I need to convert that into vector form. So the position vector of the point becomes I plus 2j plus 3k, and the direction is obviously 3i plus 2j minus 2k. So therefore the equation of the line, which can be written in the form r vector is equals to a vector plus tb vector. So that is basically r vector is equals to I cap plus 2j cap plus 3k cap plus t into 3i plus 2j minus 2k. So that's it. You just leave the equation there itself. We don't do much with it. Next one. Find the vector equation of the line this. So you are given the equation in Cartesian form. You are going to write this in the vector form. Now, obviously remember which one represents what. So let me just take you through. These are the points, these are the coordinate of the point through which the line is passing, and these are the directions. So therefore, if I remember that, then it becomes easy for me to write. So just check this. What I have written, x plus 3 it is given, so therefore minus 3 is one of the coordinate. Y minus 5 is given, so 5 is one of the coordinate, and z plus 6 is given, so minus 6 is another coordinate. So therefore the coordinate of the point, or the position vector of the point through which it is passing, that is minus 3i plus 5j minus 6k, and 2, 4, 2, that is the direction. So therefore it will become 2i plus 4j plus 2k. So therefore that's how you convert the Cartesian form into vector form. Let us take the next one. Find the Cartesian equation of the line which passes through the point this and parallel to the line this. Now, whenever you are given any line parallel to another line, then we must have the same direction ratios. So let us first see what are the direction ratio of the given line. Now, in this case, the direction of ratio of the given line is this 3, 5 and 6. So therefore, whatever line that I am going to find out, that line also must have the same direction ratio. So therefore, now there is one small thing we need to deal with, that is, whenever we are talking about the direction ratio, we must have the numerator in all the cases in the form x minus x1 or y minus y1 or z minus z1. So there has to be this form where this x, that is the current coordinates, are free from any other coefficient. So there must not be 2x, 3x or 5y, anything. So x, y and z, they must be free from any coefficient, and x minus something or x plus something, y minus something or y plus something. So it can't be the other way around. So we have to write the numerator in all these forms. Then whatever comes in the denominator, they are the direction ratios. So therefore, I have done the change, if you can see, and therefore the direction ratios are 3, minus 5 and 6. So which are also the direction ratios for the line which we are going to find out. Fine. And now it is told that the line passes through the point minus 2, 4 and minus 5. So therefore, the equation of the line is going to become x plus 2 by 3, y minus 4 by minus 5, and z plus 5 by 6. I hope this is clear. Number 7. The Cartesian equation of a line AB are given 2x minus 1 by 2, 4 minus y by 7, and z plus 1 by 2. Write the direction ratio of the line parallel to AB. So basically, you need to write the direction ratio of this line itself. Now you can see the line is not given in the standard form because there is 2x minus 1 and also 4 minus y. So I need to bring it down to standard form. So let us take up the equation of the line as it is given. So this is what given. Now I need to remove that 2 from x, and I also need to change the sign of y. So therefore, what we can do, first we can divide the whole thing by 2. So if I do so, I have x minus half by 1, right? And 4 minus y, if I just do the sign change, then it becomes y minus 4. And for that reason, 7 becomes minus 7. So now this equation is in standard form, and hence the direction ratios are 1, minus 7, and 2. Right? Let us take the next one. The Cartesian equation of a line are 6x minus 2 is equals to 3y plus 1 is equals to 2z minus 2. Find direction ratio of the line and write down the vector equation of the line through the point 2 minus 1 minus 1, which is parallel to the given line. So quite a lot of thing given. So let us first take the first part, that is, first we need to find the direction ratio of the given line, and you can see the line is not given in standard form. So first I need to convert it into standard form, and then I need to find the direction ratio. So the line is given this, and I need to do some manipulation. So you can see 6x, 3y, 2z. So I need to remove all the constant first. So the best thing to do is divide it by 6 on all the side. So you can do it that way by dividing everything by 6. Or let us first take 6 common out. So if I take 6 common out, so it becomes x minus 1 by 3, 3 into y plus 1 by 3, and 2 into z minus 1. And so now I can divide the whole thing by 6. If I do so, then I get x minus 1 by 3 by 1, y plus 1 by 3 by 2, and z minus 1 by 3. So therefore, the direction ratios are 1, 2, and 3. And now I need to find the vector equation of a line which is passing through the point 2, minus 1, and minus 1, and having the same direction ratio. So therefore, the required equation is this: 2i minus j minus k plus t I plus 2j plus 3k. Fine. Next, number 9. Find the coordinates of the point where the line through 5, 1, and 6 and 3, 4, 1 crosses the zx plane. So let us first find the equation of the straight line, which is important, and then we can go on finding the point on the zx axis. So let us first find the equation of the straight line. Now this is 2 points given, so we can find the equation of the straight line using the 2-point form. So this is basically this, that is x minus 5. I have just done it in a short, so you can guess how it is coming. So it is coming basically x minus x1, y minus y1, z minus z1 by y2 minus y1, z2 minus z1, and y2 minus x2 minus x1, y2 minus y1, and z2 minus z1. So 3 minus 5 is minus 2, 4 minus 1 is 3, and 1 minus 6 is minus 5. So that's the equation of the straight line. Now I need to find the point on the zx axis through which the straight line passes. So if this is the equation given in the symmetric form, I can always write that any point on the straight line can be written off in that form. How can I say so? You can see very easily. If I multiply this minus 2 with t and take this 5 on the other side, then it becomes 5 minus 2t, and then this becomes 1 plus 3t, and there you go, 1 plus 3t. There's a phone brand itself. Now if I multiply minus 5 there, then it becomes 6 minus 5t. Fine. So now it is told that it crosses zx plane. So if it is crossing zx plane, I know that the y coordinate has to be 0, because on zx plane the y coordinate is always 0. So therefore let us put y coordinate equals to 0. So that is 1 plus 3t is equals to 0. So t becomes minus 1 by 3. And let us put it back into the coordinates. So therefore the point on the zx plane through which the straight line passes is given by this 17 by 3, 0, 23 by 3. Fine. Find the coordinates of the point on the line x minus 1 equals to y plus x minus 1 by 2 equals to y plus 2 by 3 equals to z minus 3 by 6, which are at a distance of 3 units from the point 1, minus 2, 3. So let us first find the general form of the line. So the general form of the line can be written as this 1 plus 2t, 3t minus 2, 3 plus 6t. Now it is told that distance between these 2 points is given 3. So let us find the distance. Now it is just that we need to solve it. So just let us solve. So 40 square plus 90 square plus 36t square. So that is 49t square. That is 7t. That is equals to plus minus 3. So t becomes plus minus 3 by 7. Put it back into the coordinate. Therefore, the 2 points are 13 by 7 minus 5 by 7, 39 by 7, and 1 by 7 minus 23 by 7, and 3 by 7. Fine. Now let us move to the next one. Show that lines x minus 4 by 1 is equals to y plus 3 by minus 4 equals to z plus 1 by 7, and x minus 1 by 2 show that the lines x minus 4 by 1 equals to y plus 3 by minus 4 equals to z plus 1 by 7, and x minus 1 by 2 equals to y plus 1 by minus 3 equals to z plus 10 by 8 intersect. Also find the coordinates of their point of intersection. So obviously, if you remember the criteria for intersection, that is a2 minus a1 or a1 minus a2, both are fine, dot b1 cross b2, this should be 0. So let us do that. So now let us first find which one is x1, y1, z1, x2, y2, z2, a1, b1, c1, and a2, b2, c2. So if after identifying that, then we know that this determinant should be 0. So let us check if it is coming out to be 0 or not. And exactly this determinant comes out to be 0. And hence we can say that the lines intersect. But now I need to find the coordinate of point of intersection. So therefore what we need to do, we need to solve them simultaneously. So let us consider the first one, x minus 4 by 1 is equals to y plus 3 by minus 4 equals to z plus 1 by 7 is equals to lambda. Lambda is any constant, so I was using t all the time. So let me now make use of the constant lambda. So after we have used the constant lambda, so I can write x is equals to 4 plus lambda, y is equals to minus 3 minus 4 lambda, and z equals to 7 lambda minus 1. And let me do what? Let me also do it for the second line as well, but in this case let me use a different constant, that is mu. So the x is equals to 1 plus 2 mu, y is equals to minus 1 minus 3 mu, and z is equals to 8 mu minus 10. So what we need to do, we need to find two separate equations in lambda and mu. We need to solve it to find the value of lambda and mu. So now, obviously, for the point of intersection, the point has to be common in both the cases. So therefore, 4 plus lambda has to be equal to 1 plus 2 mu, and minus 3 minus 4 lambda has to be equal to minus 1 minus 3 mu. So that gives me two separate equations in terms of lambda and mu. Let us solve them simultaneously. After solving them, I get the value of lambda as 1 or the value of mu as 2. Put it in either of the two equation and I get the point of intersection as 5, minus 7, 6. So do that calculation for yourself. I am just skipping that out because it is routine calculation. You can do it all by yourself. Now let us move to the next topic, that is angle between two lines. Now, to find the angle between two lines, I need the direction cosines of the two lines, that is L1, M1, N1, L2, M2, N2. Or if I know the direction ratios also, from there also I can find the direction cosines. So that is not a problem. And the angle between the two lines will be given by cos theta, that is equals to L1, L2 plus M1, M2 plus N1, N2, which is basically the dot product of the two direction cosines. So if you have the direction ratios, so you can do it directly from here as well. So you are basically actually doing the dot product of the direction cosines, but when I am given the direction ratios, so all I need to do, find the dot product of the direction ratios and divide by the square root of it, sum of the squares and their square root. So that is the modulus. Fine. Now let us do it here also. Now obviously I haven't written the vector form, which is pretty easy to see that what the vector form is going to be. So if I check now, if B1 is the direction ratio of one line, B2 is the direction ratio of another line, so B1 cap is the unit vector and B2 cap is another unit vector. And basically what I am trying to do here is cos theta is equals to B1 cap dot B2 cap, right? So that's basically what we have to do in vector form. Now if I am not given the unit vectors, or if I can't find the unit vectors directly, or we can write this as B1 vector dot B2 vector by modulus of B1 vector into modulus of B2 vector. Fine. So either way. Now let us move to the problem. Find the angle between each of the following pair of lines, and these are the two lines given in the vector form. So first I need to identify the B1 and B2, that is I minus j minus 2k, and here it is 3i minus 5j minus 4k. So therefore this is B1 and this is B2. So therefore cos theta is b1 dot b2 by mod of b1 mod of b2, and after calculation we get cos theta is equals to 8 root 3 by 15. Let us leave the answer to that. So that is theta is equals to cos inverse 8 root 3 by 15, and we know that this is going to give us some angle. Now let us move to the problem. Next one. Find the equation of the perpendicular drawn from the point A 2, 4, minus 1 to the line this. Now it is told that I need to find the equation of the perpendicular. So now let us start how to do it. First I need to find the direction, not the direction, I need to find the general coordinate of the points on the line. And once I have found that, it is told that I have to find the equation of the perpendicular. So therefore, I know that the direction ratio of this line with the perpendicular, if I do the dot product, then it must be 0. So let us first find the direction ratio of the perpendicular. Now, if this is the coordinate of the straight line, and this is the point given, then the direction cosines will be given by this minus this individually. So it is basically, this is the situation, this is the line given, here is the point A given, and I need to find the equation of this line, this perpendicular line. Fine. So therefore, first what I have done, I have found the general coordinate of this straight line. So this is this, and I know the point A. So therefore, how to find the direction ratio of this line? Just subtract. This is like your P minus Q kind of a situation. P is one of the P is the terminal vector, Q is the initial vector. To find the direction ratio, you do P minus Q. So therefore, this is one and this is another one. So let us do that. So therefore, the direction ratio is given by this. Either one minus the other one. Then this direction ratio and the direction ratio of the straight line, the dot product must be 0. So let us find the dot product and then let us equate it with 0. After calculation, it becomes t equals to 1. So therefore, after putting this t back into the equation, here, then I can find the direction ratio of the perpendicular line. So therefore, the direction ratio of the perpendicular line is minus 6, 4 minus 7 minus 3, and 7 minus 9, that is minus 2. So therefore, that is x minus 2 by minus 6, y minus 4 by minus 3, and z plus 1 by minus 2, as it is passing through the point 2, 4 minus 1. So this is your required equation of the perpendicular. Now, next one. Find the foot of the perpendicular drawn from the point 0, 2, 3 on the line x plus 3 by 5, y minus 1 by 2, and z plus 4 by 3. Similar question. So all we need to do is first find the equation of the perpendicular line and then again solve. Or I need not find the equation of the perpendicular line. You'll see what I'm going to do. So let us first find the general coordinate of the straight line. This is the general coordinate. And then let us find the direction ratio of the perpendicular, which is something like this. Now, as the lines are perpendicular, so what I can say that the dot product between the two direction ratios must be 0. On solving, I get the value of t as 1. Let us put this t back into the general equation of the straight line, and that will give me the point of, the foot of the perpendicular. So therefore the foot of the perpendicular is 2, 3, minus 1. Go through the problem once. I'm sure you'll be able to get it. Next, find the equation of the line passing through the point 2, 1 and 3 and perpendicular to the lines this and this. Now here what is given, that you are given that the straight line is passing through a single point, and also it is given that it is perpendicular to two lines. Now I know that if anything is perpendicular to two vectors, then that is basically the cross product of the two vectors. So therefore the direction ratio of the line which we are going to find out must be the cross product of the direction ratio of the two lines which are given. Then only the third line is going to become perpendicular. So therefore let us first find the direction ratio of the third line, that is by finding the cross product. So therefore after finding the cross product, do give it a check. The cross product gives you 4i minus 14j plus 8k. So that is the direction ratio of the line which we are trying to find out. And it is also given that it is passing through the point 2, 1 and 3. So therefore equation of the line is going to become x minus 2 by 4, y minus 1 by minus 14 and z minus 3 by 8. So therefore that is our required equation. As simple as that. And now let us move to the final topic of the chapter, that is skew lines and the shortest distance between two skew lines. Now what is skew lines? Obviously in case of 2 dimension we don't have the concept of skew lines, but in case of 3 dimension we have it. That is, in case of 2 dimension we know that if there are two lines, then the two straight lines either can be parallel or they can be intersecting. There is no other way out. But in case of 3 dimension, the two straight lines can neither be parallel nor be intersecting. So there is a third kind of a situation which is called the skew lines. So the lines, they are not parallel to each other as well as they are not intersecting each other. So they are basically in just two different planes. So therefore they are called skew lines. And whenever we have two skew lines, then we always try to find what is the shortest distance between the two skew lines. Fine. Now let me take equation of two straight lines, that is r equals to a1 plus tb1 and r equals to a2 plus sb2. Now these are skew lines given. Whenever we are talking about shortest distance between two lines, always remember we are mainly talking about two skew lines. Because whenever I am given two parallel lines, I won't be using the word shortest distance. Why? Because between two parallel lines the distance is constant, so we are not going to make use of the word shortest distance. We are just going to say what is the distance between the two lines. But whenever I have two skew lines, I will make use of the word shortest distance, because as they are not intersecting or they are not parallel, so therefore at different places the distance between the two lines is going to be different. But of all the different distances, we need to find out what is the shortest distance. So that shortest distance is given by modulus of a2 minus a1 dot b1 cross b2 by modulus of b1 cross b2. So just remember that. And obviously it's Cartesian alternate. It's a huge thing, but obviously when we are calculating we can understand what we are going to do. Fine. And also if I am given two straight lines which are parallel, then the distance between the two straight lines is given by b cross a2 minus a1 by mod b. Fine. So these are the two formulas that we need to remember. So let us take up the problems. Now this is basically a derivative from the previous one, that is, if I'm given a point outside the line, then how to find the distance from that point to the line. Fine. Now let us take up the question. Find the shortest distance between each of the following pair of lines. Now, once again, when the word shortest distance is being used, always remember that these two are skew lines. So just let us find all the different details, that is A1, A2, B1 and B2, put it into this formula. You can do it all at once, or you can do it separately, finding the different parts, that is A2 minus A1, B1 cross B2 separately, putting it into the formula, and I get the shortest distance between the two lines as 3 root 2 by 2. Now obviously do your calculations. Next, find the shortest distance between each of the following pairs of lines. Once again, it is given in the Cartesian form. So first I need to find A1, A2, B1, B2. That is, I need to first write them in the standard form, and then after writing them in the standard form, which I have written, you can see, and then I have found out what is A1, what is A2, what is B1 and what is B2. Now obviously you may ask the question that can I mix in between the Cartesian and the vector form? Obviously you can, but always remember that you must write your answer in the exact form which is given in the question. So if the question is given in the Cartesian form, your final answer should be in the Cartesian form. And if it is specifically mentioned that find the vector equation or find the Cartesian equation, then you have to definitely do it in that particular way. But otherwise, if nothing is mentioned, always write the final answer in the form which is given. So now again, routine calculation, find A2 minus A1, find B1 cross B2, then put it into the formula, and so therefore you get your shortest distance as this 138 root 17 by 17. Now obviously I'm not explaining the calculation, of you can do it all by yourself, just give it a check. Find the vector equation of the line passing through the point minus 1 to 1 and parallel to the line this, and also find the distance between the two lines. Now obviously the first part is simple, which we have already done for trying to find a parallel equation. So the direction ratio remains same, all that changes is the point. So therefore the equation parallel is given by this, and then I need to find out the distance between the two lines. So now these are the two parallel lines, so therefore the distance between the two lines is given by B cross A2 minus A1 by mod B. Now which one is A1 and which one is A2? Obviously A1 is 2i plus 3j minus k, and A2 is minus I plus 2j plus k. You can just interchange, it doesn't matter. Then B is basically the direction which is same for both the lines, that is I minus 2j plus k. And now you put it into the formula, calculate, and you have the distance between the two parallel lines as root over of 83 by 6. Obviously don't forget to mention the units, because distance means it has got some unit. Number 19, find the shortest distance between the two lines. Now obviously here there is a small trick that which we need to understand. Here they are giving this question which may confuse you a little bit. Why? Because you see they are making use of the word shortest distance, but if you look very closely, that this one and this one, they are just scalar multiple of each other. See, I minus j plus k and minus I plus j minus k. So it's basically minus 1 times this one. If you just multiply this with -1, you get this. So therefore, I know if two lines are parallel, then one direction ratio must be scalar multiple of the other. So therefore, these two lines are basically parallel lines. So they are not skew lines. So what you will do, by looking at this shortest distance, you go on using the formula for the skew lines, but that is not it. We are going to make use of the formula for the parallel lines. Fine. So that is exactly what I have written, that the lines are parallel. So you need to be very careful about that. So always check the direction part. So we always need to check the direction part. If it is given same, or if it is in scalar multiple of one another, then sorry for that. So first we need to check the direction part, and after checking the direction part, once you see that they are not equal, so you know that they are skew lines. If they are equal, then definitely, or equal or scalar multiple, then they are parallel lines. So from there, again putting it into the formula and calculating, so we get the distance between these two parallel lines as root over of 26 units. Last one. Prove that the lines this and this are skew lines. Now remember how to prove that they are skew lines. First, I need to show that they are not parallel to each other. That is the first thing. And the second thing is that they are not intersecting. So to show that they are not parallel, first I need to write them in the standard form and check their direction ratios. Now if the direction ratios are scalar multiple of each other, then they become parallel. If they are different, then I can say that they are not parallel. So in this case, I can see directly that they are not equal. So therefore, they are not parallel. So you may ask the question why 1, 2 and -2. Here also I have 2, -2, 1, -1. But remember this, the order matters. It really doesn't matter where they are. It really doesn't matter if there are the same numbers, but also in which order they are. So 1, 2, -2 and 2, -2, -1, they are different numbers in different orders. So that is very important. So it proves that they are not parallel. So now all I need to do is I need to check if they're intersecting or not. So for checking intersection, I need to show that a2 minus a1 dot b1 cross b2 equals to 0. But if I'm trying to check that they are not intersecting, then that this dot product must not be 0. So if this dot product is non-zero, which is obviously I'm leaving to you, please do it all by yourself. Check it for yourself that this dot product is not coming 0, and hence I can say that the lines are not intersecting, and hence that proves that these two lines are skew lines. Fine. So that's it. That is the class. Hope you have understood, and as always, if you have any doubts, please get the doubts clarified. Thank you.